The time has come to take everything that I've developed in my Scratch program and integrate it back into the main codebase. While I'm working the new shader and features into the graphic system, I'm going to be moving pieces around in the API, so it's also a good time to start my pass over the API to address some issues there. Alright, let's see how it goes. My first step is to map out the graphic system that I already have in the codebase. While I know the main principles of how it all works, there are a lot of details that have gotten fuzzy in my memory since the last time I worked on it. In this step, I'm using a notebook and reading through all the code to map out what's relevant and where it lives. I just need a picture of how all the code is currently structured and how the code files map to the layers of the system so that I can think through where the new code is going to go and also how the API refactors are going to be done. When I'm done with the mapping, here is what it looks like. While I'm building that map, I'm also gathering up all of the to-dos. I have them scattered throughout the code that makes up all of these layers, and I want to bring them all into one place. And once they're there, I can start to strategize at a high level about which tasks I'm going to do first and which ones I'm going to put off for later. Alright, now I'm ready to start making some changes. First, I have some namespaces with really long names, and that's starting to get pretty annoying. So I want to pick some name abbreviations and acronyms for all of the graphic system namespaces. While I'm thinking about naming, this is also a good opportunity to do a pass over the naming scheme of my files. In particular, I want to switch off of a particular bad convention I've been using. Up until this point, whenever I have a layer that defines an abstraction with potentially separate backends for different implementations, I was using the name essential for all of the parts of that layer. So for instance, if I have an abstraction layer, that file that defines the abstraction, that gets the name essential, and then all the files that go and describe how the implementations work, they also got the name essential, just with the name of the backend included too. This name essential is long and it doesn't distinguish between the abstraction layers and the implementation layers, so I can easily get a little bit lost in that. And it's not a very exact description of the purpose of all of these files. So what I'm switching to is having the abstraction file have the name ABS for abstract, and then the implementation files all have the name impl, as well as, of course, the name of the backend that they are implementing. So for instance, if it's a Win32 implementation of the operating system abstract layer, then it would be Win32_OS_impl. Another big naming decision that I make here is to drop the name tool2d and just call it my render layer. The point being that this is the only render layer in the codebase. If I was trying to support multiple render layers that are tuned for different purposes, then it would start to make sense to give each one a different name to distinguish them. But after all the time I've spent on this problem, I'm realizing that there are some issues I need to work out before I'm going to know how I would even go about supporting multiple render layers. I'm not going to get into what those issues are, but point being, I'm not actually prepared yet. I would need to go and equip myself with some other ideas that I don't have yet. So for now, a name that assumes there's just one render layer accurately reflects the architecture I actually know how to build. as I am renaming my layers, I also want to fix their organization into files and folders a little bit. I was putting all of the graphics related code inside of a folder called GFX, but I was also treating that GFX as a layer of its own. And after trying to remember how all these layers relate to one another, I think it'll be better to adopt a more strict convention of how I'm going to organize layers into files and folders. So from now on, a layer is going to be organized in the following way. First, a layer will be in a folder that is at the root of the source tree. I'm not going to put folders inside of folders arbitrarily. If something's called a layer, then there's a folder for it, and it's at the root of the source tree. A layer may be made of several faces, and some of those faces will get folders, but not all of them. So a face may be the abstraction, and the abstract face will go into a single file or into a set of files that are labeled abs, but they'll all be in the layer's top level. Then there might be a number of locally provided implementations. These are the implementation faces or the backends, and those faces will each go into their own subfolder named after the implementation. So for instance, I have my os_abs.h is the abstract face that goes at the top of the OS folder, and then the Win32 folder underneath OS is the subfolder that contains the implementation of that abstraction in the Win32 operating system. That's the idea. No other subfolders are going to be allowed anymore. If I have a layer and it's got a folder, then that folder can only contain subfolders that are these implementation faces. Finally, I'm also going to have some layers have this idea of a user face or user faces. Those faces will also not go into separate folders. And the purpose of these faces is that they're not abstractions or implementations of an abstraction. They're just plain old concrete code, something that is defined and implemented once. I think this is going to be a lot easier than trying to represent the way things relate to each other in more complex ways. For instance, trying to represent dependencies or similar purposes by putting things inside the same folder. It seems logical on one end, but when you come back to it, you are kind of just left with this feeling of sorting it out. There's no regular meaning of a folder in that setup. So I think it's going to actually just make it easier to communicate correctly to my future self using the file system if I stick to this more strict meaning of folders and layers and how they relate to each other. Another thing I want to change is my draw layer. I've gone back and forth on this one because it's kind of a nasty issue. I initially introduced the layer so that I could have some code that would tie together fonts and rendering without baking fonts and knowledge of fonts into the rendering layer. I did that because I don't want someone who's porting the rendering layer to have to fuss with fonts. The problem with this is that the draw layer just ends up feeling like the user-facing part of the render layer. And so when I think about how to optimize both the API feel and performance at the same time, I'm going to want to treat both as part of the same unit of thing, right? I don't want to have to think about how am I going to optimize the low-level thing and ignore how the user is going to interact with it and ways that the user interacting with it might be able to make it more performant, or the ways that good API feel might require more performance work in other areas than what I'm paying attention to, and so on and so on. So making it all part of the same unit is going to make that a lot easier to do that kind of work. So I think with my new concept of faces and layers, I can sort this out in a different way, and I can do it by allowing each face to have different dependencies even if they're a part of the same layer. So what I can do is fold the draw features back into the render layer and call it the user face of the render layer. Remember, the user face is like the helper part. It's implemented once. It's the stuff that the user interacts with, not that an implementer interacts with. The user face can have a dependency on the font layer, and I can still keep the abstract face and the implementation face free from that dependency, so they won't be depending on fonts. That way, someone writing a port of the rendering system won't deal with fonts, but when you go to use the system, yes, it'll force you to drag fonts in, but it'll also automatically bundle in all the font features with all of the rest of the features in the rendering layer. I also want to make it easier for users to include all of these layers, so I did another pass making sure each layer has an inc file that is set up in the same way. And then I equipped the render layer with some extra features for automatically initializing a graphics API so that the user of a render layer doesn't have to fuss with the graphics APIs if they just want to target the render layer. I want them to be able to treat that as a portable target, and if they have to manually set up D3D or manually set up OpenGL, then they're going to have to manually also set up the sort of context awareness that lets them switch which thing they're statically linking to the render layer, rather than just say include the render layer and it just automatically works. And then I set up some selector macros and stuff so that you can control the render layer and how it initializes the graphics API for you. Doing this pass clarified an issue that's been confusing me for a little while. The render layer is currently set up to statically link like all of the other layers in my code base. And that also means the backends are effectively exclusive. I'm required to pick exactly one backend for my render layer whenever I go to build a program that uses the render layer. But in this case, it would be a meaningful idea to say you want to swap out the backend of the render layer dynamically, or even have two different simultaneously operating backends. You know, if I have, for instance, a debug window that I coded up in OpenGL, but then the main window is doing its graphics in D3D, there's no reason that shouldn't be able to work. And if I want to port that program around, but not have to port the debug window around, that might be a reasonable thing to expect. But I can't do that right now because I can only have my render layer backed up in one particular way in any given build. So I would need to do some work, and I don't have the tool set up to manage it yet. But at some point I want to come back and revisit this idea of dynamically abstracting the render layer instead of statically abstracting it. After doing all of that, here's the final organization of the graphic system layers by folders and files. And if I want to, I can add arrows into this diagram to show how the layers and their faces depend on one another. So the GFX has no dependencies to anything else, at least anything else inside the graphic system. Of course, all of these still depend on things like base and OS to some degree. But within the graphic system, GFX has no dependencies. Then the OpenGL layer and the D3D layer are both meant to represent those APIs themselves, and they have a dependency on the GFX abstract face. That way, for instance, OpenGL can be implemented on different operating systems because it doesn't depend on the implementation face of GFX, just the abstract face of GFX. The render layer has a dependency on the GFX abstract face as well, so it can do things like talk about the windows that are being rendered to and stuff like that. The OpenGL backend for the renderer has a dependency on the OpenGL layer itself, or in particular the abstract face of the OpenGL layer. And that way, the render backend that is implemented in OpenGL is operating system independent because it doesn't depend on a specific OpenGL bootstrap system, but it does depend on the OpenGL abstract face so that it can assume that OpenGL is set up and working. And finally, the user face of render depends on font, and that way I've isolated the dependency on font to the portion of the render layer that faces the user, and the backend stuff is all free from that. Alright, I've pretty well gotten my head around how this whole system works again, and I'm ready to integrate the new shader and graphics features. This part requires updating the render layer's abstract face, the part where I describe what I'm going to submit to the backend, because I've changed the vertex data a little bit. And a lot of this is still parallel to what I have, but as I'm going, I take the opportunity to remove some extra steps of compute that I was doing in Scratch. Because in Scratch, I was having the CPU do the fix up on the vertices. So for instance, I was having it rounds to make sure that I wasn't getting pixels dropped by having partially covered pixels. I wanted to round the rectangles or round my quad so that the smaller the left and bottom side got rounded down and the top and right side got rounded up, ensuring that I touched all the pixels that I was supposed to touch. And I also applied rotation on the CPU side. But that's not going to work in the way that I have things set up in the code base because I already have instancing set up there. And so I'm not actually submitting vertices with separate p values. I'm just submitting a list of quads and one template of the two triangles that make up a quad. So I either have to unroll the instancing that I already have built or leave it in and do this work of moving the fix up from the CPU to the GPU. But this was work I was going to do during the optimization pass anyways. I just decided not to make more work for myself, and I did later, and I did a little bit of work now to rearrange things so that the GPU is now doing all that vertex fix up. And finally, I need to take some time to rework the user-facing part of the render layer. First, I want to expose all the new features that the new shader has through this render layer so that a user can actually use them without dropping down to the lower level stuff. And I'm also not super happy with some of the original design decisions I had. I had this implicit context thing. I was trying to make it really easy to just make calls and start drawing without thinking too hard. But after thinking about it and discussing it with Ryan Fleury, who's written more of these layers than I have and thought about this a little bit more than I have, I'm pretty well convinced that this implicit thing is just a little bit too bare bones. Instead, what I want to do is have a thing where the user can create a list. I'm going to call it an r_list for the name of my type here. And that list is going to manage batches of quads automatically still. So the user will still not have to manually manage all of the batching work that needs to happen. But instead of submitting those batches automatically, they're getting accumulated onto this list and the user submits them when they want to. And this extra tweak means you can do a couple of cool things. It means you can explicitly control when something gets rendered, and you can do things like out of order layering. So I could do some work that does some render batching, prep some stuff, but doesn't render it right away. That way it can go later on in the render pass, even though it got computed earlier than something else, right? I can play around with the order of when things get computed versus when they get rendered a little bit more freely. And it also lets me do stuff like caching. So I can take an old render list and save it and use it again multiple times. Alright, with that, I am one step closer to wrapping up this graphic system. I've integrated the new shader, but I didn't actually go and set up the sRGB features, which I still want to do. So that's what I'm going to be doing next time. See you then.